Hey everybody, welcome to part 3 of the Kinematics tutorial, I guess you'd call it. So right now, this is the video where I think the problems start to get interesting because they become more difficult. We're talking about accelerated motion now, not just motion with a constant velocity. And remember, the goal of this video, this playlist, is to help you guys understand a different way to look at and attack the problems. And I think the best way to do that is always by looking at the velocity graph, because you have everything there. You've got the area underneath it is your displacement, the velocity is the graph itself, and the acceleration, as we're going to talk about in this video and the next one, is the slope of the velocity graph. So enjoy. If this video helps you, please like and subscribe, and here we go. What I want to start talking about now is what happens when an object accelerates. So the first question that I have for you is, do you know what acceleration means? Okay, because in physics we have to be very specific. We have to have a really good understanding of what exactly we mean when we say that. So, well, let's just talk about it. We'll figure out the exact definitions as we go around. So think of this. This particle is starting at 0. So I have it sitting right there. Okay, and now I'm going to speed up. So let's imagine that we go in time frames of 1 second. And let's just figure it this way. So imagine the particle is going to start moving to the right, but it's going to increase in its speed, okay? The speed is going to change. So maybe during the first second, so from t equals 0 to t equals 1 second, maybe the particle moves 1 meter. So it ends up like right there, okay? Now, that's 1 second. So remember, right there, that's 1 second worth of movement. Now imagine from time t equals 1, from 1 second, to time t equals 2, it's going to move farther than 1 meter. So let's just say that it moves, in this case, so it moved, for the first second it moved 1 meter. Let's make the second, it's going to move 3 meters. So that means it's going to move ahead from where it is, it's going to move ahead 3 meters. And it's going to land right there. It's going to move to the right 3 meters. So in this first second, it moved 1 meter. In the second second, it moved 3 meters. And now it's at position 4. So remember, this time frame was, I don't know, just write 2 seconds, because it was actually 1 second that it occurred in. It was just the second. So let me, the second. The second. All right, now let's say so now in the third second, it's going to speed up more. So that means it's going to go farther than it did in the second. So let's just say instead of going 3, it now goes 5 meters. So now it goes 5 meters ahead. So that's 1, 2, 3, 4, 5 meters. So this here would be the third second. Okay, and now it's here. So now if you were watching this thing go, you'd see this thing go across the screen. You know, it would move slowly at first, and then it would gradually pick up speed and go through there pretty quickly, because every second it's covering more distance. So that's sort of what it means to when I say it accelerates, meaning the velocity is changing. And I know I keep saying speed, and I'll pin down these definitions as we go on. Right now I'm just trying to make sure that you understand what's going on. So we're speeding up, and that's how that goes. Okay, I want to point something out now about this graph. And notice I didn't name it. I didn't call it a velocity graph, or I didn't call it anything. I just want to make a note of something, and I want you to think back to what I said about a particle that's accelerating. Every second, it covers more distance, okay? So let's look at this graph. Let's say I go for 1 unit on the x-axis, and the problem I want you to do is I want you to find the area underneath that. Call it a curve, but I know it's a line, but the area underneath that line. And so basically what I've made is for underneath that line, that's just a triangle, and it's 1 by 2, right? And then the area of that triangle is going to be 1/2 the base, which is 1, times 2, which is the height, and then that's equal to 1. Okay, great. Now, let's look at the second interval here, from here to here. Just like I did before, I looked at the first second, the second second, the third second. Now I'm looking at these intervals on this graph. So I look at the first interval. Now I'm looking at the second interval. So I'm looking at this one. And I want to figure out what the area of that region is. So let me be clear. I'm only looking for that second weird trapezoid type shape. I want to find that area. Now, the way I think is easiest to do it, we can just count the boxes. So I know that the length of that side is 4. The length of the other side is 2. I already have that there. So now I'm going to break that up into a rectangle and a triangle. So the area of the rectangle down here is just the base, which is 1, times the height, which is 2. So that's going to be 1 times 2. And then there's that triangle on top, which has a base of 1 and a height of 2. So this is 2, and that's 2 for a total of 4. So that's going to be, I got to add to that, it's going to be 1/2 1 times 2, 1/2 base times height, which gives me 2 plus 1, which is equal to 3. So what I noticed is in the first interval, I got an area of 1. In the second interval, I got an area of 3. So basically, what's kind of interesting about this, I want you to start thinking about this with the collecting distance thing, right? Is if I look at the area under the graph, and the graph is now not a constant graph, but an increasing one, every interval I'll accumulate more area. In the same way, when something's speeding up, every time interval it accumulates more distance. Let's do the third one just to make the point and drive it home. So again, I know that this height's 4. Now I want to figure out in the third interval, I want to figure out the area of this shape over here. So let me outline what I want in black. I want this, this, and this, that area. So I'm going to do the same thing I did before. Break it up into a rectangle on the bottom and a right triangle on top. This is 1. This bit right here is 4. And this side right here is 2. So then the area of the rectangle is 1 times 4. Plus the area of the triangle on top, since that's 1, is 1/2 the base, which is right here, times the height, which is 2. So that's going to give me 4 plus 1, which is 5. So in that time interval, I accumulated more than I did last time. And then the other one, I accumulated more than I did the first time. So what I'm trying to set you up for is that the area under the velocity graph makes a lot of sense, that it would be the distance traveled by the particle, because as time goes on, if you're accelerating, you're going to accumulate more distance every second, just like the way the area under the velocity graph accumulates more area each second. Hey, I'm glad you're still here. So now we sort of made it to the end of this, where I'm explaining where I'm going to be going in this, and hopefully I was able to shed some light onto like why it makes sense that the area under the velocity graph is equal to the displacement. So the next video, now we're really going to start being particular with our terms and pinning everything down, and get to at least solving one problem in that video, and the subsequent videos will have different problems worked out. I would like to point out, we're not using any of the kinematics equations yet. We're looking at the velocity graph first and making sure that we understand how to use that, and then later on we'll move on to the equations, how to use those. All right.